We all know situations in daily life where we only want to do something if a certain condition is fulfilled. We only go out for a walk if it's not raining, or if you score more than 50% of the points, the exam is passed. This kind of decision making can be solved in Excel by using the if function. The if function performs a logical test and returns a specified value for a true result and another value for a false result. We will learn in this video how to use the if function correctly and what it's needed for. Additionally, we take a closer look at the count and the COUNTIF function. In this video, we will look at the syntax of the if function, apply the if function working with 3 different examples, work with the count and COUNTA function, and use the COUNTIF function. If you would like to download the sample data, I will provide a link below in the description. The if function in Excel consists of 3 arguments. While the first argument is a logical test, the second and third argument specifies what happens if this test is true or false. As the if function is the first Excel function in this series of videos which requires more than one argument, one important comment on the used list separator in between these arguments. Depending on the regional settings of your operating system, the used list separator is either a comma or a semicolon. For those of you who are interested in more details, if the decimal separator you're using to enter a decimal number in Excel is a period, then Excel requires a comma as a list separator. Those of you who enter a comma as a decimal separator for decimal number values need to use a semicolon instead. This means that the syntax of the if function on your computer looks either like this or that. Both versions are basically identical except for the list separator of the arguments, that is, as said, either a comma or a semicolon. If you are not sure which of the 2 options is the right one for you, simply check the tooltip window that opens once you enter a function in Excel and look for the used separator. The logical test is to be considered a logical statement or proposition which is either true or false. Let's, for instance, take an exam which is passed with a score greater than or equal to 50 points. To determine whether a student passed the exam, we formulate the logical statement, the score is greater than or equal to 50 points. This statement can either be true or false. If the statement is true, then the student passed the exam, while otherwise the exam is failed. The theory needs to be translated now into the syntax of the if statement. For this, let's open the first sheet of this lesson's Excel workbook. We have here a list of exam results given. We start by typing the equal sign followed by the if function. To specify the logical test as the first argument of the if function, we need to translate the logical statement, the score is greater than or equal to 50 points, into an Excel expression, which is C2 is greater than or equal to 50. To continue with the second argument, we need to enter the list separator next. On my computer, with my regional settings, I need to enter a semicolon. Please remember that you might need to enter a comma. The second argument tells Excel what it is supposed to do if the logical test is true. As the exam is passed in this case, Excel should return a pass, and this is exactly what we enter as the second argument. Please note that any text returned as output of the if function must be put in quotes. Finally, we must specify with the last argument what Excel is supposed to return if the logical test is false. As the exam is failed in this case, we enter fail. After closing the bracket, we can hit enter and we get a pass for the first student. Afterwards, we select the cell with our first formula, double-click the fill handle, and we have instantly the results for all our students. The if function can not only be used to return a pass or fail, but also for calculations. Let's open the next sheet of our workbook. For the next example, we use the same initial data, but this time we calculate the percentage of the exam result. Additionally, there are some students who did not take the exam due to illness. For these students, no percentage should be calculated. Let's first enter 2 additional rows on top to enter the total exam points in the upper left corner. To insert a new row, we right-click the row indicator of the first row and click Insert from the context menu. If we need to insert multiple rows, we're selecting the same number of rows we want to insert, right-click the selection and choose Insert. In a similar way, we can also delete rows. Now we enter total points in cell A1 and 100 in cell B1. Next, we enter the if function in cell D4 to calculate the percentages for those students who attended. This time, we need to check if a score exists or not. If no score exists, nothing is to be done. Otherwise, the percentage is to be calculated. A possible formulation of the logical statement can be: the cell with the score is empty, which allows only true or false as possible answers. Translating this into Excel looks as follows. C4 is equal to an empty string. If you haven't seen what I've just entered, an empty string is equal to 2 quotation marks directly next to each other. If the logical test is true, we want Excel to return an empty string. If the logical test is false, we take the score in cell C4 and divide it by the total points in cell B1. Don't forget to set absolute cell references for the total points. Finally, we copy the function to the remaining rows and we're done. Let us extend this example even further. We again determine the result, but do not only distinguish between pass and fail, but between pass, fail, and sick. This requires that we test for more than one condition and take different actions depending on the result of the logical tests. Technically, we must nest 2 if functions together in one formula, which is often referred to as nested if function. We start with the first logical test for an empty score result. If this is true, we return sick. If the logical test is false, which means that our student participated in the exam, we must check if the exam is passed or not. Therefore, we enter as the third argument a new if function with a logical test that the score is greater than or equal to 50 points. If the test is true, we return a pass, otherwise a fail. Don't forget to close the formula with 2 brackets, one for each if function. Afterwards, copy the formula to the remaining cells. In our next example, we determine the number of enrolled students and the number of participants in the exam. The number of participants can be calculated with the count function, which returns for a range of cells the number of cells that contain numerical values. We type in cell H2 an equal sign and enter the count function followed by the cell range C4 to C29. As empty cells are ignored, it returns 22. If we do need to count not only numbers but also text, we can use the COUNTIF function to count all enrolled students in the list. We type COUNT_A in cell H1 and specify the range A4 to A29. As a result, we get the total number of 26 registered students. Be aware that COUNT_A also counts cells that look empty but actually aren't blank, like for instance cells that include an empty string returned by our previously entered if function. To demonstrate the difference, let's count the number of non-empty cells using COUNT_A for the range C4 to C29 and D4 to D29. It returns for the score column 22, but 26 for the percent column. As a last example, we create a result table and count how many participants passed or failed the exam and how many were ill. First, we enter the 3 possible results in cell G4, G5, and G6. Please make sure that you write the words exactly like the output of the if function. The syntax of the COUNTIF function is very simple. It consists of 2 arguments only. The first argument defines the range within which we want to count, while the second argument specifies what is to be counted. To count the number of passed exams, we type COUNTIF in cell H4 and enter as the first argument the range E4 to E29. Let's directly add absolute references to the range. Next, we enter as second argument a relative reference to cell G4 to search for the past exams. Remember to pay attention on using the right list separator within the Excel function depending on your regional settings of the operating system. Once we hit enter, the COUNTIF function returns 13. If we set the cell and range references correctly, we can copy now the formula to the next 2 cells and get 9 and 4 as result. This video was a bit longer, but hopefully still interesting. In the next video, we will deal with time and date values in Excel. Thanks for watching.